We just finished talking about hypothesis testing. Now we're going to talk about linear correlation and scatter diagrams. Before we can represent bivariate data, which is data involving two variables, we must decide which variable will be used to predict the value of the other variable. So, for example, it seems reasonable to think that as the speed at which a golf club is swung increases, the distance the golf ball travels also increases. So we might use club head speed to predict distance traveled. We call distance the response or dependent variable, and club head speed the explanatory or predictor or independent variable. And we've talked about response and explanatory variables before. So let's write a definition here. The response variable is the variable whose value can be explained by the value of the explanatory variable. For example, an engineer wanted to determine how the weight of a car affects gas mileage. Determine the explanatory variable and the response variable. So one way we can do this is by using the sentence, the response variable depends on the explanatory variable. So in other words, does it make more sense that the weight depends on the gas mileage, or the gas mileage depends on the weight? So in our case, I think it makes more sense that the gas mileage depends on the weight of the car. So that means that our gas mileage is the response variable, and weight of the car is the explanatory variable. This is important because when we go to make our scatter diagrams, we always put the explanatory variable on the x-axis and the response variable on the y-axis. And we'll talk about that more in just a minute. Let's talk about how to draw and interpret scatter diagrams, which are also called scatter plots. So, a scatter plot or scatter diagram is a graph that shows the relationship between two quantitative variables. Remember, quantitative are the ones dealing with numbers that are measured on the same individual. Each individual in the data set is represented by a point in the scattergram. The explanatory variable is plotted on the horizontal axis, which we sometimes call the x-axis, and the response variable is plotted on the vertical axis, which we sometimes call the y-axis. Let's look at another example. A golf pro wants to investigate the relationship between the club head speed of a golf club measured in miles per hour and the distance in yards that the ball will travel. He realizes other variables besides club head speed determine the distance a ball will travel. And here you should try and think if you can figure out what other things those might be. And when you're ready, you can restart the video. So other things would be club type, ball type, the golfer, or the weather. To eliminate the variability due to these other variables, the pro uses a single model of club and ball, one golfer, and a clear 70-degree day with no wind. The pro records the club head speed, measures the distance the ball travels, and collects the data listed in Table 1. So let's draw a scatter diagram of the data. So here, our club head speed is the explanatory variable, and the distance is the response variable. So on our horizontal axis, we have club head speed in miles per hour. We should always label what's on each axis. And our vertical axis is distance measured in yards. So at a club head speed of 100, so we go 100 on the horizontal axis, we have a distance of 257 yards. So 257, 58, 55, 56, 57, so about right here. At 102, we have 264. At 103, we have 274. 101 is 266. 105 is 277. 100 is 263. 99 is 258. And 105 is at 275. So if you notice, we have a couple places where we have club head speeds that are the same, but the distance is different. That's okay, we just put them on our scatter diagram anyway. So we just did this scatter plot by hand, and in a minute I will show you how to do it on the calculator. And by in a minute, I mean in the next video.